In this problem, we have to use the direct comparison test to determine whether this series converges or diverges. So before you use the direct comparison test, you should look at the series and try to determine what you think. Does it converge or does it actually diverge? You can do that pretty easily by ignoring the lower order terms. So if you write down this piece here, you'll notice that when n is big, the fact we're subtracting 1 is pretty irrelevant. If this was 20 million minus 1, it really wouldn't matter that we're subtracting 1. So you can ignore the lower degree terms and constants. So this series will pretty much behave like this series. Right? They're pretty much the same. Okay. So this is a divergent p-series because p is equal to 7/8 and it's less than or equal to 1. And recall that a p-series diverges when it's less than or equal to 1. So now that tells us that we have to show divergence. So recall that if you have two series, say a sub n and b sub n, and the a's are smaller than the b's, if the sum of the a's diverges, because the b's are bigger, the sum of the b's also diverges as well. So in order to show divergence, we have to show that this is bigger than something, where if we add up that something, that sum will diverge. So what we can do is we can drop the 1. And let's just double check that. This fraction is bigger than this one because this number here on the bottom is smaller than this number, right? This is n to the 7/8 minus 1. That is smaller than n to the 7/8. That makes this fraction bigger. You can look at it backwards. This fraction is smaller than this fraction because this number here, n to the 7/8, is bigger than this number, which makes this fraction smaller than this one. So now we just have to explain why the sum of these guys diverges. So and this infinite sum, as n runs from 2 to infinity, of 1 over n to the 7/8 diverges, it's a very delicate argument, by the p-test, since, well, why does it diverge? Well, because p is equal to 7/8, which is less than or equal to 1. So we've shown that this is bigger than this and that the sum of these diverges. Therefore, because this is bigger than this and the sum of these diverges, by the direct comparison test, the sum of these guys should also diverge as well. So that's, in particular, that's our original series. So thus, our original series, I'll just say OG, OG means original, our original series, beautiful, beautiful problem, diverges by the direct comparison test. So I'll just say DCT. It's really important to carefully justify your work in these problems. Go through all the steps. It's important to write everything down and explain it thoroughly, 100% thoroughly. I hope this video has been helpful. Take care.